Welcome to the video about simplifying expressions. Let's get started. First, you need to know that an expression is a number, a variable, or a product of numbers or variables. For example, 5a plus 3b. It's an expression. The big thing you need to remember here is that expressions do not have an equal sign. All right, if you have an equal sign, then you have an equation. Expressions do not have an equal sign. All right, let's go over a few more terms. First, the coefficient of a term is the known number directly in front of the variable. If no coefficient is present, then it is assumed to be 1 or -1, depending on the sign in front. All right, let's go back to our example up here. Right? Our coefficients, the coefficient of A would be 5. That's the number in front of the variable. The coefficient of B would be the 3. All right, apparently Smart Notebook wanted me to draw a triangle instead of a box. All right, if there is no number, if you just see X, we have an understood, we've got a ninja 1 here, right? If it says -X, then the coefficient is still a ninja 1, but we need to remember it's a negative ninja 1. All right, moving on down. A constant is a term with no variables. It's a known number. So if our expression is 5a plus 3, 3 here is a constant. There's no variable with it. It's a known number. Two terms are equivalent expressions if they have exactly the same variables with the same exponents. For example, 3a squared is equal to 3a squared. You notice how everything matches up. My 3's match, my variables match, my exponents match. All right? If they don't have the same exponents, then they don't match. You're also going to know that besides equivalent expressions, you're going to want to know that two terms are like terms if they have exactly the same variables with the same exponents. All right, getting back to this. If I have 5a plus 3a plus 7a minus 2a. All right, same variables, and they all have the same exponents. I can combine these. So how many a's do I have total? Well, 5, 6, 7, 8. 8 and 7 is what, 15? Minus 2, so I have 13a total. All right, this is important for simplifying. All right, when you simplify an expression, you combine all of the like terms. To do so, you add or subtract the coefficients on like terms following the signs in front. Okay, this is exactly what I just did right here. This result gives you a new coefficient, after which you write the same variable and powers as they had before. All right, that sounds a little wordy, but let's look at the examples. All right, simplify each of the following expressions. So start at the left, and let's go. Okay, I have 8n. Do I have any other n's? Oh, hey, look, there's a -3n. So 8n minus 3n leaves me with 5n. All right, do I have any more n's? Nope. Okay, go back to the left. I'm done with the n's. Oh, -11. Any more just constants? Oh yeah, plus 5. So -11 plus 5 is -6. And that's as simple as it gets. You notice I have no more like terms there. All right, we can even do this for ones that are bigger and nastier looking. So let's start at the beginning here. 2xy. All right, do I have any other xy's? Yeah, right here. And that's it. Okay, so 2xy minus xy. That's just 1xy, or we just write xy. Those are done. All right, next one, 5x. Do I have any more x's? Yep, negative x. All right, so 5x minus x is 4x, and it's a positive 4x, so we want to make sure we put that positive sign in front of it. Next, 6y. Any more y's? Yeah, 7y here. So 6y plus 7y is 13y, and it's a positive 13y. All right, now that I've done, we officially need to change this order a little bit so we could be mathematically, grammatically correct. We want to put them in alphabetical order. So really what that means for this is that I need to flip-flop these two. So I'm going to say 4x plus xy plus 13y. Now remember with addition, the order does not matter. 5 plus 3 is still the same as 3 plus 5. You're going to end up with 8 either way. The order does not matter how we say it. You're going to end up with the same answer anyway. So we can reorder these as necessary to get them in alphabetical order. All right, let's look at number 3. We're going to do the same thing we've been doing. So start with the a squareds. So 5a squared minus 15a squared gives me negative 10a squared. Then we're going to do the a's. 2a plus 9a, that gives me 11a. And that's it. All right. If an expression contains parentheses, you're going to need to distribute first before combining like terms. All right. For example, let's look at number 4 and 5 here. All right. Parentheses, let's distribute this. So bring down my 5x. Negative 2 times 3x is going to be negative 6x. Negative 2 times positive 9 is going to be negative 18. And then bring down my minus 15. Now that I've distributed, I get to add combine like terms. So 5x minus 6x is negative x. Negative 18 minus 15 is what? Well, it's negative for sure. All right, 8 plus 5, 8, 9, 10, 11, 12, 13. Carry the 1, 1, 2, and 3. So my answer is negative x minus 33. Wow, Smart Notebook does not want me to draw a box today. Sorry about the triangles. All right, this one here, I've got 2 sets of parentheses, so I'm going to have to distribute twice. So I'm going to distribute the 4, and I'm going to distribute this negative 2. So 4 times m is 4m. 4 times negative 3 is negative 12. Negative 2 times m squared is negative 2m squared. So negative 2 times 5m is going to be negative 10m. All right. Now we get to combine like terms. Let's start with our biggest order one first. That means this exponent. So minus 2m squared. I don't have any more squareds. Now I'm going to do the m's. So 4m minus 10m gives me negative 6m. And then the constant, which is negative 12. And that's it. Be sure to send me an email if you have any questions. Now you should be ready to do your homework.